Hi everyone, we are Group 7. Today we'll show you a real effective exchange rate model for main country currencies. This is the outline of our presentation. We have 6 parts in total. Let's start with introduction. After the collapse of Bretton Woods system of fixed exchange rate, a great amount of effort and time has been devoted to derive the fair value of key currencies within the global financial system. People always believe that with the help of accurate FX fair value models, not only the government can come up with efficient fiscal policy, but also financial companies will be able to design profitable trading strategies. Although there are various models proposed by different financial institutions, this foreign exchange modeling remains elusive. Hence, in this project, we'll investigate what secular drivers can impact the real exchange rate, and we'll also aim to build a FX fair value model for main country currencies. Now I pass to Yuwen to give a literature review.
Our approach is on the BER model, and we introduce the long-term relationship between exchange rate and macroeconomic variables. And there are two differences between our model and BER. First, we include a variable, openness, in our model, which plays an important role in modern forex prediction. Also, our model is run by panel co-integration regression on a regional basis. And there are 3 determinants of real effective exchange rate. First, terms of trade capture the income and substitution effects from terms of trade shocks. And according to the Blood-Sass-Nielsen effect, countries with higher productivity have higher wages in traded sector. So it will also cause an increase of wages in non-tradable sector. So the exchange rate of faster growing countries will increase more. And another variable to consider is trade openness. More open regions are typically associated with lower price of non-tradables and lower exchange rate. And our data is from 1996 onwards for 2 emerging countries, Brazil and China, and 2 developed countries, US and UK. And we use a ratio of GDP to population as a process of productivity. And openness lags 12 months to limit endogeneity. So terms of trade and productivity have positive effect on exchange rate, and openness has a negative effect on exchange rate. And next, we move on to the model description.
Thanks, Yuwen. Here are the details of model we developed in this project. The method we use is panel co-integration regression of real effective exchange rate on a range of macroeconomic variables. And the specific relationship is as shown in the formula. REER for country I at time t equals to I country's fixed effect plus the panel coefficients times explanatory variables and plus error terms. A country's IER, which is a dependent variable in this project, is a trade-weighted value of bilateral effects with trading partners. And the reason we choose panel regression is because it has a few advantages compared to normal time series regression. First of all, panel data can model both the common and individual behaviors of groups. Secondly, panel data contains more information, more variability, and more efficiency than pure time series data or cross-sectional data. Thirdly, panel data can detect and measure statistical effect that pure time series or cross-sectional data can't. And lastly, panel data can minimize estimation biases that may arise from aggregating groups into a single time series. And now I will pass time to Jingyuan to talk about the pre-regression check.
Since the original BER model assumes that the input are all stationary time series, we want to perform some check to make sure our grounds are the same. First, we plot all the factors for each country we're interested in. In a below plot, without using the ADF test, we can see some of the time series are non-stationary. To still carry on using our panel regression, we did a co-integration test to ensure that the correlation is not superior given the non-stationarity. We run a Johnson procedure to check the co-integration between terms of trade, openness, productivity, and RER for each country. With 5% significance level, we conclude that there's one co-integration vector for each of the countries. Instead of solely relying on this procedure, we plot the 4 co-integrating vector. As you can see in the below plot, the 4 co-integrating time series indeed shows some stationarity as they are moving around the same mean. Therefore, we conclude there's co-integration and confident to proceed with our panel regression.
Thanks, Jingyuan, for talking about the pre-regression check. Now let's go through the panel regression results by each panel. Let's first look at the developed markets panel. As we can see, the sign of each variable matches with our intuition, namely, terms of trade and productivity have positive effects on FX rate, while openness is having a negative effect. However, out of the three independent variables, only terms of trade and openness are statistically significant. In fact, this makes sense because developed countries all share a similar level of productivity. We will revisit this when we talk about emerging markets panel. Based on the regression model, we plot the actual FX rates and predicted rates as following. The blue line is the real rates, while the red line is the predicted rates. The two graphs below shows that the misalignment between the real rates and actual rates. We can see the misalignment is minimal because it is within the range of minus 0.2 to 0.2, basically less than 5%. However, we can also see that the model is not good at capturing black swan event, like the financial crisis happened in 2008. The model has a relatively big misalignment there. However, surprisingly, we can see the model fits pretty well during the COVID-19 period. Is it just a coincidence? Actually, we think this is because the impact of COVID-19 on FX rates is more on long term. In our model, the openness is lagged 12 months to reflect the economic openness. If a country has a long lockdown period due to COVID-19, its openness will get impacted hugely. However, based on our model, we believe that the big fluctuation of FX rates will not happen immediately, but in a slow and long-run manner. Now let's move to emerging market panel. Again, we can see the sign of the variables is aligned with our expectation, but this time, all the three coefficients are statistically significant, especially for productivity. The significance of productivity once again proves the existence of Balassa-Samuelson effect. In other words, the productivity will have a larger effect on fast-growing emerging economies, which may then have a stronger FX rate. As a result, we can see a higher R-square here, which might be contributed by productivity. For the emerging markets plotting, the result is also promising. And again, the model is not able to capture some black swan effects. Next, we want to compare our model with popular purchasing power parity model, namely PPP. PPP model is based on the law of one price. Literally, exchange rates will evolve to make identical goods cost the same in all countries when priced in a common currency. The plotting result shows that PPP has a larger divergence compared with our own model, especially for China. But it has relatively better performance in developed markets. This is because PPP is not able to address Balassa-Samuelson effect. But for a model, there is no right or wrong. What is important is to choose the appropriate model that meets our needs.
Thanks, Yuxuan. There are some advantages in our model. The coefficients are significant and aligned with our intuition. The model is able to provide long-term insights on FX movements. Compared to bear model, we introduce a new variable, openness, which could help to capture some black swan events like COVID-19 country lockdown. There are still some limitations for this model. For example, we only considered 4 country currencies in total. This can be extended to a larger number of currencies in the future. Meanwhile, the 2 panels used are developed market and emerging market. In the future, this can be further segmented into exporter and importer. Another thing to mention is that if prediction of FX value for the next period is required, we need to predict the terms of trade and productivity for the next period at first, given that the value of these 2 variables is not in lag terms. The bright side of this is that compared to the traditional FX value prediction models, predicting terms of trade and productivity is relatively easier and more accurate. That's all for our presentation. Thank you for your time.